Hi, today we're talking about CCM6 prime factorization. Some definitions for you. Prime. Prime numbers is a whole number that has exactly two factors, 1 and the number itself. For example, 7 and 13. Composite. A number greater than 1 with more than two factors. For example, 6 and 25. VIC stands for very important concept. So this important concept is that 1 and 0 are neither prime nor composite. Factor. Factor is when two or more numbers are multiplied. Each number is called a factor of the other. For example, 6 times 5 equals 30, so 6 and 5 are the factors. Prime factors are just factors that are prime. For example, 2 times 7 equals 14, so the 2 and the 7, they're prime numbers, and they are the factors of 14, so they are the prime factors. Take a second and copy this down. If you need to, just pause the video, and then push play when you're ready. Okay, when we do prime factorization, there's two main methods that we use. The first one is making a factor tree. You've probably seen this before. The other method is a ladder method. You'll see this when we do GCF and LCM. So both of these methods are very important. So if I take the number 56, I need to break it down into its prime factors. Prime factorization is just that, breaking a composite number into its prime factors. So I need to ask myself, what times what equals 56? Well, I know it's even, so 2 goes into 56. 2 goes into 56 28 times. 2 is that prime number, so I circled it. 28. 4 times 7 makes 28. 7 is a prime number, so I circle it. 4 is not. 2 times 2 is 4, so I broke it down, circled my last two prime factors, and all together, I've got 2 times 2 times 2 times 7. Well, since the 2 repeats 3 times, I'm going to shorten it. And so the way that I write my prime factorization is 2 to the third power times 7. I like to use a little dot for my multiplication. I do not like to use the x because sometimes the x looks like a variable. So we're using exponents and then a little dot for multiplication. I also like to put my smaller numbers in front so the numbers are in order from least to greatest. Over here in the ladder method, I've got the same thing going on, except you'll see I have what looks like an upside down division sign. And that's precisely what it is. So I've started with my number 56, and I draw an upside down division symbol, and I say, okay, what goes into 56? And I'm kind of looking for the smallest prime number that goes into 56. 2 is that number. So 56 divided by 2 is 28. And I do that again. What goes into 28 evenly? 2 does. 2 goes into 28 14 times. What goes into 14 evenly? 2 does. 2 goes into 14 7 times. You notice that I've got a different number here than I do over here because I divided, I've got a different number here because I divided differently. Instead of dividing 4 in this step here, instead of dividing 28 into 4 into 28, I chose 2. The reason is I'm trying to get all my prime numbers over here on the left side. So when you're doing a ladder, think to yourself, what's the smallest prime number I can use with the ladder method? That'll help you out in the long run. Over here in the factor tree, you can just use any combination that comes to your head because you're breaking it down into a tree anyways. Ladder is more linear, so you really need to focus on the smallest prime number that you can pull out. We'll do a couple examples so that you can see what I'm talking about. Anyways, my end result is 2 times 2 times 2 times 7. And remember, we shorten it, so that's 2 to the third power times 7. Let's try another number, bigger number this time, 420. We're going to try it using the factor tree in the ladder method. So again, with the factor tree, like I was saying before, you can use any combination of numbers that comes to your head. Instinctively, I use 42 and 10. When I multiply that together, I get 420. That's just my instinct. So once I have my two factors, I just continue breaking them down until I get all prime numbers as a result. You just keep on breaking those factors down until you get prime factors. When you figured it out, you should get 2 squared times 3 times 5 times 7. This one's a big one. So you'll notice again, I've got my numbers in order from least to greatest. A good way to check to see if you're correct is to multiply these numbers together to see if you get 420. 2 times 2 times 3 times 5 times 7 should give you 420 in the end. Another way to double check is make sure you've got only prime numbers down here. That's why we call it prime factorization. Secondly, we have the ladder method. You can use any combination of numbers out here to the left, but try to use only prime numbers. When you're pulling out numbers, try to use only prime numbers. So I start with 420 and I think to myself, well, that's an even number, so I can use the number 2. 2 goes into 420 210 times. Then break it down again. And I saw 210 and I thought to myself, 21. 7 goes into 21, so 7 should go into 210 30 times. Since 7 goes into 21 3 times, 7 should go into 210 30 times. Then my work gets a little bit easier because I continue breaking it down. 3 goes into 30 10 times, 2 goes into 10 5 times. If you look, I've got only prime numbers here and a prime number left over down here. When I look, I've got 2 squared times 3 times 5 times 7, which is the same thing I got before. You choose whichever method you feel most comfortable with. A lot of students like the factor tree at first, and then some graduate over to the ladder. Let's try a couple together. 24. 2 times 12 is 24. 2 times 6 is 12. Then 2 times 3 is 6. So the prime factorization of 24 is 2 times 2 times 2, which is also known as 2 to the third power times 3. I'm going to do 216, but I'm going to use the ladder method this time. I know that 2 goes into 216 108 times. 2 can go into 108 because it's an even number. It'll go in 54 times. 2 will go into 54 again because it's an even number 27 times. Now 27 is an odd number, but I know that 3 goes into 27 evenly 9 times, and then 3 goes into 9 3 times. So I've got 2 times 2 times 2, which is also known as 2 to the third power times 3 times 3 times 3, which is 3 to the third power. So altogether my answer is 2 to the third times 3 to the third. This is also known as cubing a number, so I could say it 2 cubed times 3 cubed. That's my prime factorization of the number 216. Again, to check your answer, just type into your calculator 2 times 2 times 2 times 3 times 3 times 3, and that will give you 216. What I want you to do next, I want you to try these 6 problems independently on your paper. You'll push pause on the video, and then when you're ready, push play, and you'll see the answers come up. I'm only going to put the answers, so Hopefully you did this right. If you're not sure, maybe ask your math teacher tomorrow. Okay, good luck.